Now shearing strength, you know, simple meaning. This is the basic fundamental I want to discuss. Okay, don't worry, we will discuss everything, but this is the today the fundamental of the stress in strain. Suppose this is the original component. Okay, I want to discuss the shear strain. So this is the original component. Now we applied the load here. Suppose we applied the here load. So we applied a load here, force P. Okay, we applied the force here, load applied, and this is the length of the component. Suppose this is the L, and this is also the L. Suppose is our convenience L and L. Okay, so we apply the load here. So this component here, shift here. So components means here this is the shift in this manner. Okay, and this point goes to in this manner. Okay, okay. Now, so here this is the angle gamma. We take the angle gamma, and angle we want to take the here gamma. Okay, so here we obtain this the displacement delta, means permanent deformation or deformation, permanent or temporary deformation delta. If we load applied, if permanent displacement disappear, then it's called elastic load. If permanent deformation does not disappear, that is called simple permanent deformation, means inelastic load, plastic load. Okay, now here apply the shear stress. Okay, shear stress here. So shear stress applied in this manner, tau. This is the tau, and this is the here tau. So in that case, I want to discuss gamma, means shearing strain. This is the gamma. So I want to discuss this is the SHEARING. Okay, shearing strain. This is the gamma or gamma XY. Gamma or gamma XY. So here gamma is equal to basically delta upon L. Shearing strain. So here applied, suppose this is the shear stress tau. Here shear stress also tau. Okay. So here gamma, basically the shearing strain is equal to gamma or gamma XY, means XY means two-dimensional component. So here gamma XY or gamma is equal to delta upon L. So when the force P is applied, see, when the force P is applied tangentially, this is the component, tangentially, when the force P applied tangentially to the element shown here, so it's as displaced to dotted line. This is the dotted line here, as displaced to dotted line. Suppose this is the blue is the original component, and the red component is the after distortion. This is the red component after distortion. Okay, blue is the original component, red is the after distortion. Okay, yes. Once again, I am repeating. When the force P is applied tangentially to the element, it's as displaced to dotted line, where delta is the lateral displacement of the upper face of the element with respect to lower face, and its length L is distance between the two faces, these faces. So gamma means shearing strain, gamma is equal to delta upon L.